All right, hi everybody. Welcome to the section 4.4 video and lesson. And in this lesson, we're going to be learning the method of undetermined coefficients. So we're going to look at our first method to solving a non-homogeneous differential equation. So let's go ahead and look at some of these learning objectives. So in this lesson for section 4.4, we're going to be able to define the method of undetermined coefficients for solving a non-homogeneous differential equation. We're going to be able to identify the correct trial particular solution, y sub p, and then apply the solution. We're going to be able to solve a non-homogeneous differential equation with this method of undetermined coefficients. We're going to observe and apply a glitch in this method of undetermined coefficients, and of course, solve an initial value problem using this method of undetermined coefficients. So that's all of the learning objectives for this section. So let's go ahead and introduce the method of undetermined coefficients. So in the previous section, section 4.3, we learned how to solve constant coefficient homogeneous differential equations. Okay, we learned how to solve, something like a y double prime plus by prime plus cy equals 0. We were able to solve a homogeneous differential equation that looks something of this standard form. And so in this section, we're going to be able to solve something similar, but in this case, it's a non-homogeneous differential equation. Okay, so it would look something along the lines of, let me bring it up here, a similar form like ay double prime by prime plus cy, but it wouldn't equal 0. It would equal some free floating function of x, like, g of x. Okay, so we're going to be able to solve a non-homogeneous differential equation of this form now. But the great thing about this constant coefficient method is that the homogeneous part is still constant coefficient as well. So we would know how to solve this portion here. We would know how to solve this homogeneous portion of the equation. Okay, so we know how to solve the homogeneous part. In this section, we're going to learn how to solve the non-homogeneous part, but what we're going to do is combine the homogeneous and non-homogeneous together. So in this method, we'll be able to solve the non-homogeneous by finding the complementary solution for the homogeneous part and the particular solution to form the general solution to the overall differential equation, which is the complementary plus the particular. Complementary plus the particular. Okay, so here is the method for undetermined coefficients. So our goal is always to solve a differential equation of this form. Okay, so remember, this is the homogeneous part. We're going to get ay sub c, our complementary solution, and this is our non-homogeneous part where we pick up our particular solution. So we're going to combine these two to get the overall general solution. Okay, so what is this function that makes this non-homogeneous? Well, for this method, this function f of x needs to be, a constant or a polynomial or exponential or sine or cosine. And it needs to be, for a fact, a finite product or sum. Okay, it can be, inverse trig or natural log. It needs to be some finite product or sum of these four factors. Okay, So the steps to solving a non-homogeneous differential equation using undetermined coefficients. Step one, we need to solve the homogeneous part using the auxiliary equation. That's like section 4.3, which we've done before. So, this is the homogeneous part. Step two is we're going to learn in the next video, but we're going to take a guess of what the particular solution should be. And what we call that is a trial particular solution. And all of this is for the non-homogeneous part. And so what do we do next? We plug in the trial particular solution, and then we solve the differential equation. Okay, so that is the setup for this problem. We have three steps. These problems kind of take a while, so it's not expected to be a short, quick three steps, but we have the sort of algorithm to get the solution, and we try to treat it as such, okay? But that's it for this video. We're gonna pick it up from here in the next one, but thank you for watching and see you there.